It's been a little while since my last update on what I've been doing with the C256 Foenix. I have actually been pretty busy with it, but I haven't had very much to show because what I've been working on has been pretty low-level device driver kind of stuff. But I now have some stuff working in BASIC that may be of interest, so I thought I would show what I've been working on. What I've been working on is adding file commands to BASIC and file system support into the kernel so that other applications can be written to use it. What that is entailing is essentially FAT32 file system support for the SD card and for an IDE drive if you have one attached, and then FAT12 support for the floppy disk. Now, this code is not perfect yet. It's not really complete. I'm only supporting cluster sizes of 512 bytes at the moment, so I need to be able to support larger clusters than that. It's only supporting a single directory, the root directory, at the moment, so I need to add in subdirectory support at some point. But I now have something reasonably good to show. So let's get into some of that. The first thing probably to show is the directory command. That is just dir, as you might expect. And I'm going to be doing something a little different with BASIC and the file system for path specification. So it's not going to look exactly like DOS or like Unix or something like that. This is going to be a little different here. But to say where you want to do a directory listing from, you give it a string, and you can specify the device by using the @ sign and then a device, a device code or device name. And at the moment, there are only 3 device codes: S for the SD card, F for the floppy drive, and H for the hard disk. But the system can support longer device names than that. So different partitions on the SD card and the hard drive will probably be supported, and we'll have maybe numbers in there, maybe like H1 for partition 1 on the hard drive, that kind of thing. But that's all to be built in later. But for the moment, let's say we want to look at the SD card. So we would type dir @s , and we get a little directory listing. Now this directory listing is probably going to change. I'm not too terribly happy with how this is looking at the moment. But you see device name at the top, or rather the volume label at the top in brackets there. And then each file with its file size, its date, some of which are incorrect, and the time when it was created. And again, I'm probably going to change this around a little bit. But we could also look at a different device. So we can look at the hard drive, for instance. And you see I've put a different label on the hard drive. I've called this hard drive FMX0 for the 0 partition of the FMX hard drive. And I've got some files on here. So let's try loading one of those in. So I can type load clock.bas. And one of the little quirks with the file code right now is that when you use a device, that device becomes your current device for the next command. So I don't have to put a device specifier on here with the file name, but I could have. So I'll load the clock code in and go ahead and run it. And there you see it's pulling the date and time from my real-time clock. In case you want to see what that looks like, because I don't think I've shown the clock stuff yet, I just have 2 clock functions here, get time and get date, that return strings in those formats. That may not be the most terribly useful way of doing it, but that was just the way I went. Anyway. And then we can look also at the floppy drive. And at the moment I don't have anything there, but let's say I wanted to save this file to the floppy drive. I can just save it. Just like that. And after a moment, there's the file. Now, you may have noticed I made a typo there. How do I fix that? Well, I have a rename command. So I can say rename, and let's say for the moment that I'm going to fully specify what file I'm wanting to rename. So I put the @f colon there to put the device name on there. So I'm going to change clack.bas that's on the floppy drive, and I want to change it to clock.bas to fix that typo. You don't put a device specifier on there because you're just renaming the file. It's going to stay on the same device. And there it's been renamed. But let's say I think, oh no, I didn't want to save that there. I want to delete the file. Well, we have a delete command as well. And again, I can put the full specifier in there if I want. So that all works, as expected, very simply. Other commands that we have in here. So let's take a look over on the SD card. I think that's the one I want. No. Let's go look on the hard drive. So you'll notice that I have here a file called subarea.txt. That's just an ordinary text file. Now I don't have a type command in here. I've been thinking about it, but maybe later. But let's say I want to load that into memory somewhere where I can look at it. Well, we have a bload command. So I can say bload subarea.txt, and I can give it an address where I want to load that file. So that will take all the data in that subarea.txt file and load it into RAM, starting at the address 010000. Now, obviously I can't see that here, but if I go into the monitor, I can now look at that block of memory, and here you see I have a bunch of text in there. This isn't the easiest way of looking at the text file, obviously, but whatever. So anyway, I can load, and similarly I've got a bsave command that can take RAM and stick that into a file. So we have the ability to load and save both basic and binary memory data on the FMX right now, on the C256 right now. All right. And similarly, I've gone and I've added in a brun command. Now, the brun command is essentially how I'm going to support running executable binaries on the C256. Now, you could just bload a block of machine language data into RAM and then use the call statement to actually execute that code. That would work fine. But to make it a little bit simpler, I've created this brun command. And all you really do there is, as you might expect, you give it the file that you want to be run. And in this case, PGX is a special file format that I'll explain in a minute that is an executable binary. It's currently the only executable binary that the FMX kernel recognizes. However, the kernel is designed so that we could add other file formats later if we wanted to. This is just a very simple format, very stripped down and basic, just to get things running. So yeah, you say brun quote and then the file that you want to load and run. But if you have a space after that, you can also type in a parameter string. So param1, param2, 3, and so on, however many you like. So what brun will do is it will load that file into memory, and the file specifies where it's supposed to load in RAM. and it will then execute that code, but it will also provide this entire string that is shown here in a special variable or a special location memory. It will have a pointer to that string that it presents to the program. So the program can take that and use that for switches for controlling execution, or just general parameters for controlling how the program operates. So the sample PGX that I've written will simply echo out that string so you can see it, like so. The other thing that brun will do is that it will take the 16-bit value that's in the accumulator at the time that program finishes, and it will set a special variable in BASIC to that value, so that your BASIC program can call into brun, get a value back from that executable, and then change how it runs after that's happened. So in this case, we can print out the error value, and what I'm going to do is run that through the hex function that takes a number and prints out a hex string for that number. And ERR is that variable that gets set by brun. And here you can see that the sample PGX, when it finished up, it just returned hex 1234 as its result value. All right, so let me switch screens and I'll show you what this PGX format looks like. Here we go. It's quite simple. It's just a binary file, and what it does, what it requires is an 8-byte header at the very beginning of the file. So the first 4 bytes are essentially kind of a magic number identifier for the file format. The first 3 are just PGX. That just verifies that it is this PGX format. And then there's a bytecode which currently is only going to be a 1, but this value is intended to be a version number and target CPU code. So if at some point we need to change the format a little bit, or if we want to support targeting a different processor like the 68000, this byte will provide room for it. The upper nibble will be the version code for the file format, and the lower one will be the CPU number. So 1 is going to be 65816, and later on 2 might be the 68000, that sort of thing. Then the next 4 bytes are the address for loading the data. So this is where you will stick, this is where you're intending for the file data to start loading. In this case, start is the label we're using, and it's set for 020000. I have rearranged where data is being stored by BASIC, so I'm going to in the future recommend that we actually load to 010000 and have that be kind of the standard load location for executables. It's not required, but I think that's going to be kind of my recommendation on where things should go. But anyway, so the next 4 bytes is basically saying where we're going to start loading the data, and that's also going to be the starting point for the code. So you can see here is my code, or most of it. Here we go. There's the rest of the code. And I'll kind of quickly walk through this for you. I am saving the databank register and the processor status so that when it falls back into BASIC, those things are restored to what they should be. BASIC is being careful about that too, so that's not strictly necessary. This is where I'm pulling the back and returning to BASIC. This section here, I am setting for an 8-bit wide accumulator and 16-bit wide index registers. And then I have a little greeting string here, and I'm just printing that out here. So I'm using the kernel call puts, which takes the lower 16 bits of the address in the X register and the upper 8 bits in the databank register. So I'm just setting X in the databank register here and then calling puts. And then I'm taking the load, this variable DOS run param, which is down in bank 0. This is the variable, or the memory location rather, that is set by essentially by brun. Although it's actually getting set, well, yeah, it's being set in brun. So I'm taking the lower 16, the upper 8 bits of that data, the address that's stored there, and I'm essentially getting that into the databank register. That's what this is doing here. And then I'm getting the lower 16 bits of the address out of the the DOS run parameter, and I'm putting that in the X register so that I can then call puts again. So that will it'll print, this hello world, and then it will print that whole string, that whole parameter string that we had gotten. And that's really all it's doing. And then it's loading 1, 2, 3, 4 into the accumulator and returning that. So that's really all it's doing. But your binary program could be much more complicated than that. You can be parsing the data that's in that string that DOS run param points to, turning on and off different options, or looking for different files. You can provide file data and so on. The kernel is not going to be doing any parsing of that for you. It's just going to provide that data. And then you could do, whatever. You can, set up sprites. You can, set up a background screen in your bitmaps. You can be playing sound files, that sort of thing. Oh, and DOS run param, where that is, and this is going to be documented, but it's right here. It's at location 360. And that's going to be the standard location. That shouldn't change. If that does change, that's going to be considered an API, backward compatibility breaking change, and that's going to be notified when that sort of thing happens. Oh, and for completeness sake, here is the kernel entry point for that POTS function. And I'll just switch back to screens. So again, you can see, how we're printing that stuff out, and then that return value there again. And that's really it for the file system commands at the moment. Changes that I am planning on bringing to this, I will be adding in subdirectory support. So that will be coming at some point. I don't know when. One of the other things I want to add in is the ability to do booting from a device. So being able to boot from floppy disk, from SD card, or from your ID hard drive. The way that I'm intending on doing that is having a special FMX boot record on the hard drive. Oh, sorry. Well, yes, on the hard drive, but on the hard drive SD card or floppy disk. I have started working on that. However, there are some subtleties that I'm discovering around at least the volume boot record for floppy disks, so that having, other than a standard kind of FAT32 DOS boot record on there seems to be confusing some things for Windows. I do want floppies and SD cards to be able to be things that you could pop onto your PC or your Mac and have them be readable and writable on those devices, so that it make it easier for you to get stuff onto the FMX. So I need to figure out how to get that working exactly right. One of the other limitations I've got to mention is that currently only 8.3 file names are supported. So eight characters in the name and a 3-character extension. This is old school DOS. I know it's pretty annoying to have that. It might be nice to have long file name support on the system. Certainly the FAT file system allows for that. I have not coded that long file name support into the system yet. That might come, or it might not. But we'll see. That kind of segues into something kind of philosophical or whatever with the bootloader support. One of the ways that I originally had thought about supporting bootable devices was simply to look for a special file name in the root file, the root directory. So you have like a boot.pgx or something like that, or autorun.pgx or start.pgx, that kind of thing. So you have a standard file that you could put on the file system in the root directory, and if the C256 kernel saw it, then it would run that and automatically do that. Later on, I decided that maybe having the bootloader support would be better, and that the main reason for that would be if somebody wanted to get rid of the FAT file system and have their own file system for a custom operating system or for an elaborate game or something like that, if they wanted to do like exFAT, or I don't know, if they wanted to just support some other potentially better file system on their system, then having the bootloader in that boot record would allow them to bootstrap in their own way and not lock everything into the FAT support that's in the kernel right now. So that's kind of where that's going. And so when I finally get all the little niceties worked out there, then that should be working. Anyway, this code will eventually get published. I'm not quite sure when. I need to do a little bit more testing on it to feel better about where it is. I'm not 100% confident with the floppy drive support at the moment. While I've gotten my floppy working pretty well, I'm pretty sure that in other cases, for other people, there may be issues. The timing on those things is pretty ornery. If you're not doing everything in exactly the right order, the floppy drive is just like, yeah, I'm not going to load that. I'm not going to load that sector for you. And I'm not an expert at writing device drivers, and I'm certainly not an expert at those old floppy disks. So this has been a learning experience for me. Anyway, I think that's enough babbling. I'm going to edit this video and get this out here. I hope you found this interesting, and thanks for watching.